Now coming to some of the examples of the DFA. So here the some 10 to 10 are there. These 10 are some of the examples of the DFA. Coming to first one, construct minimal DFA that accepts all the strings of A's and B's, where each string starts with substring AB. This meaning is that it should contain a substring AB. After that, any number of A's and any number of B's may come. So there is no restriction after AB. After AB, there is no restriction. It may any number of A's and B's come, okay for us. So we can construct very easily. Take some state S1, some state S2, and some state S3. Here, like this, single A, single B is acceptable for us. Why? Because it says that the string should always starts with AB. And after AB, can I get any number of A's and B's okay for us? Infinite number of A's and B's okay for us. There is no restriction on this one. So 1A after B, after AB, any number of A's and B's come below, there is no restriction on this. And if if it starts with single B, in the initial state, if single B comes, then what's its meaning is that it is a dead state. Alright, it is a dead state. And on S2, if A comes, that is also dead state. So on S1, if single B comes, it's a dead state. On S2, if single A comes, that is a dead state. On dead states, any number of A's and B's come, that's also dead state. So like this, after AB, any number of A's and B's come, okay for us. But on initial state, if B comes, dead state. On S2, if single A comes, that's a dead state. Like this, you will get 4 states here. And coming to next example, same, construct minimal DFA that accepts all the strings of A's and B's, and where each string ends with AB. Means that string should ends with AB. Means this meaning is that at the end AB should be there, and before AB, any number of A's and any number of B's come, okay for us. But at the end, what should be there? AB should be there. That's the meaning of sixth question. So how we can construct the sixth question means, like this, single state S1, state S2, state S3, like this. On S1, if A comes, S2, on S2, B comes, input B comes, it will reach S3. Up to here, okay for us. And before that, any number of B's come, any problem for us? No problem for, there is no restriction on this one. Before that, any number of A's and B's come, no problem for us. So, any number of B's come, any problem for us means no problem. So, it always ends with AB only. And on S2, if any number of A's come, any problem for us, there is no restriction. It always ends with AB only. Any number of A's, B's, always ends with AB only. And on S3, like this, single A comes like this. It is also one possibility. A, B, like this, it always ends with AB only. And on S3, if I give input B, like this, AB, B, AB, AB, B, AB, AB, B, like this loop will be repeated. So these are the possibilities. For always ends with AB substring. And coming to seventh question, construct minimal DFA that accepts all the strings of A's and B's, where length of the string is exactly 3. Means length of the string always should be how much means exactly 3 means, like this possibilities. Suppose, is this 3 length string means yes, this is a 3 length string, and is this 3 length string means yes, this is also a 3 length string, and like this is also 3, like this combination of A's and B's that should contain exactly how much length means exactly 3. That's we have to construct. So it is very simple one. It is very simple like this. So take initials for seventh question. For seventh question, take S1 state, S2 state, S3 state, S4 state like this. And on S1, if I give inputs A comma B, you can give any of them, either A or B. On S2, you can give either A or B inputs. Like this, either A comma B means combination of A's and B's. Exactly how much length string should be there means there should be exactly 3 only. Exactly 3 only. After that, if single A comma B comes, after that, if single A comma B comes, where it will go means it always goes to dead state. Means it should contains exactly 3 only. It should contain only exact 3 length string only, that will be accepted. Other than length 3, it always goes to state, dead state. So this is regarding 7th question, exactly 3 length string. And coming to 8th question, same, construct minimal DFA that accepts all the strings of A's and B's, where length of the string is at least 3. At least 3 means it should contain greater than or equal to length strings. Means minimum length how much means minimum 3. Then afterwards 4 length string, 5 length string, 6 length string, 7 length string, so on. Infinite length of string is accepted. So minimum length string is what? Minimum is 3. After that you can get any length of the strings. So for the 8th question, the DFA diagram is, this is also very easy. State S1, state S2, state S3, state S4. So on S1 single A comma B, you can take any of them, either A input or B input into S2. On S2 you can give any input A comma B. On S3 you can give any input A comma B. After that, any number of A's and B's come, there is no restriction on this one. You can get any number of A's and B's. Like this, how many states you will get means 4 states you will get. That's the question for at least 3. Now coming to 9th question, same, construct minimal DFA that accepts all the strings of A's and B's, where length of the string is at most 3. At most 3 means you have to draw up to maximum of 3 only. Other than 3, this is not accepted. So greater than 3 is not accepted. At most 3 means below 3 length string means 0 length string, 1 length string, 2 length string, 3 length string is accepted. But 4 length string, 5 length string, 6 length string, they are not accepted. So at most 3 only means 0 length string, 1 length string, 2 length string, 3 length string is accepted. Same as previous question only, but small changes. So 0 length string means initial state and final state are same. 0 length string accepted means what? Initial state is itself is a final state. That's the meaning of 0 length string. So S1 is also a final state and S2 is also final state. Why means 1 length string is also accepted. No? So S2 is also final state and 2 length string is also accepted. Means like this, S3 is also final state and S4 is also final state. Like this, you will get at most 3 length string. After that, if you get any number of A's and B's, that will always goes to which state means dead state. That's the meaning of this 9th question. So at most 3 means like this, you will get how many states here means you will get 5 states. So that's the question for 9th question. Now coming to 10th question, same, construct minimal DFA that accepts all the strings of A's and B's, where length of the string is divisible by 2. This meaning is that length of the string means you have to form the string with combination of A's, N, B's. Length of the string is combination of A's and B's, and that length should be divisible by 2. That's meaning is that combination of A and B, length 0 is divisible by 2 means yes, length 0 is divisible by 2. And 2 is divisible by 2, yes, 2 is also divisible by 2. 4 length string, 6 length string, 8 length string, so on. All even numbers are, all even length strings are divisible by 2. So now first length string is either A comma B is accepted means yes, first length. Second length also combination of A and B is accepted. But you have to form initially which length string? 0 length string. So 0 length string means I already told that starting state itself is a final state. That's the meaning of 0 length string. So 0 length string is nothing but what? Initial state itself, final state. So you have to draw like this final state. Then combination of A's and B's like this, A comma B. If you draw like this means A comma B input on S to A comma B input like this, you always get even number of length strings only. See, initially starting state itself, final state means 0 length string. Then A comma B on S2, it reaches to A comma B means like this. Then you will get 2 length string combination of A's and B's. Like another loop, you will get 4 length string. Another loop, you will get 6 length string. So on. You always get even length of the string only. Like this, how many states you will get means you will always get only 2 states. This is the answer for 10th question. Now coming to 11th question, it is also similar like that. What he gave means construct minimal DFA that accepts all the strings of A's and B's, where length of the string is divisible by 5. So length of the string divisible by 5 means 0 length string is divisible by 5. 5 length string is divisible by 5. 10 length string is also divisible by 5. 15 length string is divisible by 5. 20, 25, so on. Like this, all the numbers, all the 5 length strings are divisible by 5 only. So initially, which length string is accepted means 0 length string means that meaning is that starting state itself, final states. 0 length string means I already told that starting state itself, final state. Then after single A comma B. Then after single A comma B. Then after single A comma B. Like this. See, it always forms 0 length string, then 5 length string. See, A comma B, A comma B, A comma B, A comma B, A comma B. So this is the 5 length string. Then after 10 length string, 15 length string, like this loop will be repeated. So it always forms 0, 5, 10, 15, 20 length string, so on. Then the loop repeats like this, you always get to be like this, 5 length strings. That's the question for 11th question. And how many states are here means there exist 5 states like this. So this is the answer for 11th question. Coming to 12th question, same, construct minimal DFA that accepts all the strings of A's and B's, where number of A's, restriction on the only A's only, number of A's is divisible by 2 means we have to restrict number of A's always even numbers only means see, A's restriction on the A's only, 0 number of A's is accepted, 2 number of A's is accepted, 4 number of A's, 6 number of A's, and 8 number of A's is accepted. But there is no restriction on B's. There is no restriction. Any number of B's comes okay for us, but restriction on which one? Number of A's only. This diagram also very easy. State S1, and I already told you 0 string is accepted means starting state itself, final state, and on S2 like this. There is restriction on A's only. It always forms even number of A's only. 0 number of A's, 2 number of A's, 4 number of A's, 6 number of A's, 8 number of A's, like this. Loop always repeats. And there is no restriction on B's means like this, there is no restriction on B's. Any number of B's come, okay for us. So infinite number of B's come, okay for us. So like this, how many states it all contains means it always contains only 2 states. This is the answer for 12th question. Coming to 13th question, same construct minimal DFA that accepts all the strings of A's and B's, where number of B's is divisible by. Here restriction on number of B's. He gave restriction on B's. Means number of B's contains how many means it always divisible by which number? 5 numbers. Means he gave restriction on B's. He gave restriction on B's. So how many B's should be there means 0 number of B's, 5 number of B's, 10 number of B's, 50 number of B's, like this. Number of B's always divisible by 5, but there is no restriction on A's. So he is not restricted. There is no restriction on the number of A's. Infinite number of A's come, okay for us. So he restricted on B's. So like this, minimum zero length string is 0 means initial state itself is a final state. N S2, S3, S4, S5, like this. He restricted on number of A's, like this. So here are got 5 number of A's, 10 number of A's, 15 number of A's, like this 20, 25, like this group will be repeated. And there is no restriction on B's like this. Sorry, little bit correction, like this. He restricted on B. So number of B's like this restricted, like this. So like this, 0 number of B's, 10 number of B's, 20 number of B's, 25, 30 like this. And there is no restriction on A means any number of A's come, okay for us. Like this. There is no restriction on number of A's. So this contains how many states means this always contains 5 states only. And coming to 14th question, same construct minimal DFA that accepts all the strings of A's and B's, where every string contains A as the third symbol from the left hand side. So he is saying that A should be from left hand side. From the left hand side, A is in which position? Third position. So this is first position, second position, third position. When the string comes, if you take any string from the left hand side in the third position, which symbol should be there means A symbol should be there. So in the first position, A comma B come, there is no restriction. In second position, A comma B come, there is no restriction. On the third position, it should contain which symbol? A symbol. And after that, any number of A's and B's come, okay for us. There is no restriction. But from the left hand side, in the third position, which symbol should be there? A symbol should be there. That's the question. It is also very easy one. So take state S1, S2, S3, S4, like this. First symbol A comma B come, okay for us. Second symbol A comma B come, okay for us. But third symbol should be there. What? A. L. After that S4, any number of A's and B's come, any problem for us means there is no restriction on this one. But on S3, if B comes, this always leads to which state? That state. Y means third symbol from the left hand side should be A, but not B. So if B comes, that always leads to which state? Dead states. So this contains how many states means this always contains 5 states for 14th question. A as the third symbol from the left hand side. Now coming to 15th question, same thing like that. Construct minimal DFA that accepts all the strings of A's and B's, but where A as the second symbol from the right hand side means he restricted if you take any string from the right hand side, if you take any string, suppose is the string contains A as the A symbol as the second symbol from the right hand side means yes. If you come from the right hand side, A as the second symbol. And Coming to, is the string contains A as the second symbol from the right hand side means yes. If you come from the right hand side, second symbol is A. And in the string, if A is the second symbol from the right hand side means no. What is the second symbol from the right hand side? B is there. So always if you come from the right hand side, which symbol should be there? A symbol should be there. That's the question he asked. And for this one, it is also easy one. See, state S1, state S2, and state S3. If you take like this, A, B. So is this accepted means? Yes, it is accepted. Here, what is the second symbol from the right hand side means AB. Now, on S1, if any number of B's come, any problem for us means there is no restriction number of B's. Before that, any number of B's come, there is no restriction. And on S2, if I apply small a, it always leads to which state means 1 minute. On S2, if I apply small a, this is also accepted for us. This is also accepted means AA. This is also accepted. In this case also, A as the second symbol from the right hand side only. And on S4, any number of A's comes, any number of A's come, it always contains A as the second symbol from the right hand side. And if single B comes, it will reach to S3. And on S3, if single A comes like this, AB, like this, it always ends with AB as the second symbol from the right hand side. And on S3, if we give input B like this, AB, BAB, like this loop will be repeated. Like this is the answer for 15th question. This is always contains how many states means 4 states.